Okay, so picking up right where we left off, the only thing I did in between videos, I just renamed the bricks. As you can see, they're all named brick now. I simply removed the appended number and parentheses. So I figured you didn't need to see me do that. That's just kind of busy work. So at the end of the last video, we gave the paddle movement. If you're holding a button, it moves. If you let go of a button, it stops moving. Now we need to give the bullet movement, and this is going to be the overwhelming majority of the code for this application. When you think about it, the controlling of that ball is really the majority of the gameplay. So at first it might seem odd that we have to put so much effort into it, but that's really the majority of the gameplay. So you want to make sure that this is working as intended 100% of the time. Now, having said that, it's only going to be maybe a couple dozen lines of code, so it's not that bad. And it's really the same line over and over again, just making a few tweaks. So, what we're going to do is we're going to make sure that this ball keeps moving. Because when you think about it, the way a game like this works really defies gravity. It defies physics. Because every time an object strikes another object, some energy should be lost and eventually it should slow down. But does just the opposite. Games like that, it speeds up. So if it seems a little odd that we have to put so much effort into making the ball work, it's because you're really defying physics. So basically what you're just doing is you're giving it little boosts right along, saying, okay, you hit the wall, bounce off, but don't lose any velocity. So I certainly don't want to scare anyone away. It's not that bad. You're basically going to see the same line over and over again, just with slightly different instructions. So let's get to it. So create C# ball control. Now before we get into the script itself, let's take a look at the ball and the paddle. Now among other things, we want this paddle to be immovable. When an object is created and you add a rigid body, by default it has a mass of 1. We need to change that. So we want the mass of the bullet to be as insubstantial as possible, so I'm going to drop that down to 0.01. And for the paddle, we're going to move that up all the way to 100. Now that's not going to change its movement though, as far as when you command it to move, because you've already given it an absolute velocity. So it really ignores the mass and says you are going to move at this speed regardless of your mass. But what this changes is when there's an impact, there's more force because you have more mass, or in the case of the ball, there is less force because you've just reduced the mass to almost nothing. So we set the mass of the paddle 100, we set the mass of the ball to 0.01. Now let's take that ball control and put it onto the ball object, and let's get into that script. I've already typed this out in a text file, so don't mind me while I copy and paste. I will explain everything as we go along, so don't be intimidated by the text file. So we're looking at the x and y velocity. So we're going to look at what's known as a vector 2. A lot of variables store a single value, like a string or an int. It has a single value. With vector 2s, you're actually storing two values. You're storing an x component and you're storing a y component. You're saying what is the x velocity expressed as a number, and what is the y velocity expressed as a number. And so what you can do is you can extract one of those. You can do currentVal.x or currentVal.y. You can make a change to it. And that's what we're really going to do. We're really going to be monitoring the x and the y velocities and then making changes accordingly. Let's look at the start section now. So start occurs when the object gets instantiated. Two things. We're taking that ball val. So ball val is equal to new vector 2, 3, comma, negative 3. Get component rigid body 2D. As we said, objects have components, so here's the ball object. Here's the rigid body, so get component rigid body 2D. change the velocity to the ball velocity, which we just declared. Now, that gives it its initial movement. So actually, let's save that and let's watch that happen. See how it just rolls like that? We're going to get into why it does that, but at least now you've given it movement. So let's address the bouncing. So right click, create physics 2D material, and let's call this bounce mat. As you can see, there are only two attributes. There's friction and there's bounciness. Let's bump that up to 3. And depending on if you're going to make a full-fledged game and actually distribute it, this is going to be something you're going to want to take careful consideration of, because again, this affects the movement of the ball, and the movement of the ball is the overwhelming majority of the gameplay. So this you actually may find yourself changing. So let's now watch what happens when we apply that. So click on the bullet, take the bounce mat, and bring it up to the circle collider. So it really is a portion, it's an attribute of the collider, which makes sense, because how do you want it to react when there's a collision? Well, we want it to bounce. So now watch what happens. Now you have bounce. And you saw how quickly it bounced, and it actually broke because it went through this. So that's something else we're going to address. Okay, so let's tweak that a little bit because that really bounced too much. Don't want to get too much into the detail. We want this to be workable, but again, this is the broad strokes, understanding what you have to change. So we'll run that one more time and then continue. See, not nearly as much, and now it bounced a few more times before it broke. Okay, so now in the update section. So as it says, update occurs every single frame, once per frame. In fact, let's delete these now that we've reviewed that. So current vel, so we declared that at the beginning. Current vel is equal to get component rigid body 2D velocity. So here we did something different. Here we used get component rigid body 2D velocity to change the velocity of an object. Here we're using it to extract the velocity of an object and drop it into a variable. So here you're really seeing the difference between this and this. We're looking at what the current velocity is and what the applied velocity is going to be. So with every single frame we're saying, let's take a look to see what that velocity is. Now you're going to see a similar set of statements. It's really one idea repeated several times. Okay, so if parenthesis current vel dot y is greater than 6 close parenthesis. So this is what I was saying earlier. You can actually look at a single component. Well, maybe I shouldn't use the word component. You can look at a single vector. So you're looking at the y vector of current vel. If the current y velocity is greater than 6, we're going to do something. What are we going to do? Well, here we go again. The same get component rigid body 2D velocity. So when we're done, you're going to see this about 10-15 times, but just keep in mind, it's really just the same line of code over and over again, just with a slight tweak. So if the y vector is greater than 6, get component rigid body 2D velocity equals new vector 2, current vel dot x. Okay, so where you first saw this new vector 2, we gave two constants. Here what we're saying is whatever the current x vector is, keep it. So if it's moving at +1, keep it at +1. If it's moving at -3, keep it moving at -3. So that's why it's so important to grab this velocity every single frame. So whatever the x vector is, keep using it, but the y vector, cap it at 6. So in other words, if this starts moving greater than a +6, cap it at 6. In other words, that bouncing that you just saw won't happen anymore, that it won't go that fast. I'm going to do one more though, at least for the vertical. So, same idea. If the y vector, if current vel dot y is less than -6, so this was greater than +6, this is less than -6, and again, get component, rigid body 2D, velocity equals new vector 2. Again, you don't want to change the x vector, so current vel dot x, once again, we grab that every single frame. If current vel dot, you keep using the current x velocity, but change the y to -6. In other words, cap it. So if it's less than -6, so it's going really fast in a downward direction, cap it at 6. This is another control point. You might figure this is too slow. Maybe it's going to be -7, -8. Maybe you're going to turn this into a variable and that there'll be buffs and debuffs that let you cap what the speed is. Now we're going to do it for the x components. Really, the x components, or should I say the x vectors, really the x vectors probably shouldn't be necessary, but we put it there just to be safe. And with a low resource game like this, it only takes a minute to add, and it, like I said, since it's so low resource, it's not going to adversely affect performance. So same idea. If the x vector is greater than 6, cap it at 6. So here, it's the x that you're capping, and here you're using the current y velocity. And then one more time for -6. Alright, so that's attached to the ball. So let's run it again and watch what happens. No longer goes crazy. It now keeps at a reasonable speed. And again, you may decide that that's a little bit too slow, but that's where you would change that. Now you probably noticed something. When it hits the paddle, it really loses its X. It goes straight up. So that's the kind of thing that we're going to do next. So right now we've capped the speed, so that's the first thing. Next thing we have to do is we have to make sure it's not losing an entire axis. So it's hitting this and it's losing its X and just going straight up. So we're going to do things like that to make sure that doesn't happen. Now before we go any further into altering the way the ball responds to collisions, we really should put in the brick collision as well to give us a more accurate sense of what you're going to see the ball doing for the most part. So the script for the brick is actually really simple. Just right click, choose create, and we'll make a C# script, and we'll just call this destroy brick, because really that's all it's going to do. You can call it whatever you want. You could call it brick control. Now we have multiple bricks, but that's not a problem. Click on the top one, hold shift, click on the bottom one, and now you can add a component to all of them at the same time. So just drag and drop that destroy brick script. You click on these individually and you look over to the inspector, you'll see that it did indeed successfully add it to all of them. So now let's go ahead and open up that script. So when we want it to work so that when the ball hits the brick, it deflects off of it even though the brick gets destroyed. So the problem is if we immediately destroy the brick, the ball just goes right through it. Again, you might have a power-up that gives it like a penetrating factor, and so this is where you'd have to make a modification, but for now we just want it to bounce off. So what you actually need to do is have an ever so slight delay. So So what we want to do, and we don't want to do this in start or update, we only want it to happen when there's a collision. So we have to create a new routine, and it's a predefined one, so you have to get this exactly right. It is case sensitive. So void on collision enter 2D collision 2D other brackets. So capital O C E D, capital C, capital D. Again, this is predefined. It's case sensitive, so if you change capitalization, it won't work. Unity won't realize that this is the function that you're trying to use. It will just think that you're trying to do something on your own, something that you created. So this script is attached to the brick. So if there's a collision with the brick, what we're going to do, destroy game object. Now, while that statement is legitimate and it would work under normal circumstances, again, in these circumstances, we want a delay. So there's a second argument here that is optional for the statement, but is really a necessity in this scenario. So you add a comma and then a delay. It's going to be a decimal. This is normally done in seconds, so delay 1, 2, 3, 4, whatever. Well, we want it to have the ever so slight delay, so we're going to do 0.1, so 1/10 of a second, and because it's a decimal, we've got to add the letter F. And you'll see that a lot, like if you're using a decimal for the vectors, if you're explicitly stating a constant and it's a fraction, you got to add that F. So now, that's really all it should take to make the brick destroy. So the ball should hit it, bounce off, and then destroy. There we go. So you might want to make the delay be slightly less because it's noticeable that it's a delay. Let's see if we can do 0.05 if it makes much of a difference. That's fine. That looks good. Hardly noticeable. Now, what we're going to do next is we're going to work more with how the ball moves. So we're going to go back to our text file and we're going to get the next section. So in the ball control, outside of update, outside of start, just like we did with the destroy brick script, we're adding another collision. So same syntax, void on collision enter 2D collision 2D other. So now this is attached to the ball. So now we're giving instructions to the ball for when it's colliding. So again, we're using an if statement. The whole thing has to be in parentheses. So we said, okay, we're looking for a collision with other. So if other.gameObject.name equals, and yes, it has to be a double equal sign when it's in an if statement, left border. That's what we named this, left border. So if the object that the ball is colliding with is named left border, then we want to do something. Once again, we're going to change the velocity, but this is the more complicated than what you've seen up to this point. So, get component, RigidBody 2D velocity, new velocity. Take the current x velocity and reverse it. So if the x velocity is 5, multiplied by -1, making it -5. So 5 would be moving left to right. So it's 5. If it hits a wall, Although in the case of this code it's saying the left wall, we're going to apply it to the right as well. So if it's moving at a +5 and it collides, +5 gets multiplied by 1, which is what? -5, which means it now bounces off. Now in the case of the left wall, the left border, so I pointed at the right, but right now this is only looking for the left. So take the x velocity and reverse it, but keep the current y velocity. And then we're going to do the same thing for the right wall. If other.gameObject.name equals right border, get component, RigidBody 2D, velocity equals new vector 2, and this line is identical. So, since the get component statements are identical, technically you don't have to write it like this. You could do a single if that checks for left border and right border. That would be a more concise way to do it, but this is a little messy to look at to begin with, so I don't want to overwhelm you. But yes, you could indeed have this be combined as a single if statement with a double ampersand in the middle, checking both of these values, and then just doing this. So for optimization, you could do that, but in a game like this, it's not going to make a difference. It's not going to impact performance. So, the script is attached to the ball. The script is looking for a collision. If the ball collides with the left or right border, it will bounce off of it, not lose any of its momentum. It simply flips the direction that it's moving in horizontally. Okay, so that's looking like about it. Now, when we play this, you're probably going to see anomalies occur, like, okay, we have to adjust for this, have to adjust for that. I'll do a little bit more, but for the most part, you get the idea. You get the idea that if there's a collision, you really need to make sure it's doing what you want it to do. Because, like I said, what we're doing here really defies, this type of game really defies physics. Because an object shouldn't keep moving faster, faster, and faster. It should be moving slower. Okay, see that? Shouldn't do that. So, let's see what happened. That's what... I didn't save. So that, actually, I'm glad that I did not save it, because you could see what happens. I accidentally did the right thing, and that is, you'll see how it's going to behave differently now when it hits the left wall. Oops, or I could just entirely miss. See how it bounced off the wall now? It's because that code we just added. Again, we're really messing around with physics. Physics shouldn't work this way, so that's why you have to make those, for want of a better term, those interventions. And I'm sure if you play long enough, you'll find other things that need to be changed like this. This is going to be a little bit hard to change because of its position. Okay. And the other thing that you can do, you could deal, you could make these kind of be like bumpers on a pinball machine, and that they actually, whereas right now the velocity stays the same, or should I say gets flipped, you could actually maybe increase the velocity. That way you don't get those odd trappings. But like I said, if you play it long enough, you're going to see a glitch like that, and it's just a matter of coding to avoid that.